have done. I started.
Okay.
Yeah, I started.
Okay, thank you.
So it's getting recorded now.
Thank you.
So you can see that your data should be pasted in the SPSS space. And interestingly, I want to bring your attention to these two bottom links, icons. There's a data view and the variable view. And you can see that here you can see the data. And here you can see the variables. But the problem I can assure you, you will be facing is that when you check it in your computer, there is no list of variables yet. Because can you see that? Can you see that this data is in SPSS? Can you see it in your computers? Huh? Okay, but can you also see these labels like revenue, PE? There we go. Because you have to type them. You have to type them. You have to type them. So because there are not many variables, the one possibility is that I could have simply copied these. I mean, if you don't like to, oh, what happened? It went off. The one option is that you can type in these names. You can just copy and paste, but do you even need to see this big screen? Because you're seeing in your computers anyways.
What's this one flash which has no title?
Sorry?
What's this one K in the spreadsheet?
1K?
No, K.
K. Ah, okay.
What is it?
No, it's nothing. Just ignore it. Well, I'm not, because I'm only taking those full data. Don't take K and L column. You just ignore them. You only need to copy and paste from sorry, I didn't tell you. You only need to copy the data from A column to J column. There's no need to copy or anything with K and L. I can just actually delete them, just get rid of them. So we don't need them basically. I was telling you that either you type in these names, these titles, or just copy and paste. But how to copy and paste? Well, this is the way. I can just copy it. But is it showing in your computers? Huh? Even if it doesn't show on the screen, but does it show through the Zoom? Yeah, because I'm doing through the Zoom. So even though the screen, the big screen is annoyed with us, still you could see in the Zoom. So you can also be in Zoom, by the way, so that we have the same set of information. So the one possibility is that you can copy this whole thing and maybe open a new spreadsheet. If you go to paste special, In the paste special, you have a transpose function. Yeah, transpose. The transpose function is that if you copy a row, it would show as a column. So I on purpose chose these when I pasted the titles, I on purpose chose the transpose pasting. Okay. Are you missing anything? Even though you may know it, but I deliberately choose to assume that you don't know anything. So that's why I'm trying to be, that's why I'm going with these baby steps and assuming that we all are at the same level. You don't look at the big screen, go to Zoom. Even those who are sitting here, go to Zoom, you will see my screen appearing there. So you can assume that you're in your apartments. It is in the discussion forum. There's a one message sent by Seher. The message is sent by Seher in the discussion forum of finance and corporate governance. And this message is sent on here. You can see here. Now you can see the screen also, by the way. So it's here. So she has sent all the Zoom meetings. So choose the 27th of October meeting. Okay. So you can see here that all these things are appearing, but I suggest you that SPSS is very moody. If you type like this, P/E, as I got it, it will show the error. It will show the error. So choose it PE like this. If you type in D/E, it will show the error. So type in DE. Anyway, whether you are typing it in the manual way or you are copying and pasting, you see that you will see in SPSS, once again, we are back in SPSS. And here you can see the variable view. So here you can see the revenue, PE, firm OPR, market OPR, DE, innovativeness, and so on and so forth. And we see these variables here. So you would see this kind of picture appearing. If you don't see it, bring to my notice, please. So here, SPSS is having a problem that if you, for example, PE, if you put some slash in between, it doesn't recognize it, it shows error. Or if you give a space between P and E, it will still show the error. So make sure that all the variable title, there is no strange character and there is no space. For example, if I type D space E, look, it will not show. It shows the illegal character. So make sure that in your variable view, in the names of variables, neither space nor strange character. So it has to be in the one go. Small letters, capital letters, doesn't matter. It doesn't matter. Some variables can just show up funnily, but I don't consider them. So only those variables we consider which has been properly labeled, which has some name. Like for example, your first variable is revenue. You know what is revenue? You know the price to earning ratio. The price to earning ratio is the share price, one share price of a company divided by the earnings per share you get. And the firm OPR is firm, the company in questions, operating profit return. So operating return, you can say. And MAR OPR is market operating return. So what is the average of the market profitability? DA is debt to equity. I hope you know that the company's finance come from two sources, D to E, D and E, debt and equity. So if the company is having the book value 100 euros and 60 euros are coming from debt and 40 is coming from equity, then D to E ratio would be 60 divided by 40, 1.5. And innovativeness, how innovative the company is. The firm, but I'll come back to innovativeness in a second. And then the company stock return, the firm stock return, you know how to calculate it. You are doing it already in many tasks. So simply copy and paste the firm's stock return. And then I choose the index stock return. And because in this case, because these companies which the data I pasted here, they all come from UK. They are listed in London Stock Exchange. So I chose and these are the big companies. So I chose FTSE 100 return as the variable. So this is my variable, the index. And these variables, they just keep showing up. They just disturb you, don't worry about them. But we only focus on these variables which are labeled. Okay? Now, very important thing, I want to bring your attention to, look folks, if you have any doubt at any stage, don't wait till I complete. No, just ask me when the problem occurs. Even there's a wee bit of doubt, stop me there. Any questions so far? Seher, on your end?
No, students are still quiet.
They're still quiet, okay.
Yeah.
But of course, it's getting recorded, so you can watch it or you can ask me in the future also, no problem. So this we will go very slow and maybe many times. I want to stop and I want to bring your attention to this variable called innovativeness. And I take you to the data view. Here you can see that revenue, P2E, firm operating profit, market, debt to equity ratio. By the way, I forgot, I'll come back to innovativeness yet, but I want to bring your attention. Can you see here the variables? They are numeric, 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 and numeric. They all are numeric. But it may happen, listen carefully, it may happen that when you copy and paste data in SPSS, it shows string. It shows string or something else. Can you see here string? Sometimes when you paste data, it shows string. What is a string? String is a kind of small rope, I think. We never can do anything. We can never do anything in SPSS if the data is in the string form. Well, we can do something, but the possibilities would be very limited. So my first word of advice is that after you have these variables, make sure that your data is all in the numeric form. Your data is all in the numeric form. And if it is not in the numeric form, like here string, you have the option. Just see there's some dots here. Click them. Just click them and choose to numeric option. Here we go. Now the data become numeric. We must have here numeric data. And guess what? In the numeric data, it shows the width of the variable, how wide, because wide means, for example, if it is 1 million, in 1 million, there is a 1 and 6 zeros. Do you get my point? In 1 million, if you write 1 million, you will write 1 and 6 zeros. It means the width of the variable is 7. 6 zeros plus 1, this one numeral. So, but we don't do anything to it. But here we need to do something. We can change decimals. I recommend you that there should be some decimals, like I chose 5 decimal places here. Because if there's no decimal, you know what will happen? Your 1.234 and your 1.979 would be considered to be 1. And if it is 0.979, it will be considered 0. So therefore, once you have the numeric thing, once you choose your variable to be numeric, make sure that you have the decimal points. I can't subscribe you, I can't tell you how many decimal points you should have, but I think 4 to 5 decimal points should be there, right? But for example, if the variable is string, just in case, then see what? You can't choose decimals. Look, there's no decimal. I just chose the variable string and there's no decimal, and I can't even change it. So that is why I said that always have the variable numeric. And once you have the numeric, then choose decimals. 1, 2, 3, 4, 5. I think if the decimals are too many, then the system says, hey, you can't choose so many decimal places. But I think 4 or 5 decimal places are fine, no problem. And then there is nothing else to change. So make sure that when you have the variable view here, you have the labeled names of the variables with no space, no strange character. And all the type of variable should be numeric. If it is not numeric, you can change it. Look, there is a box here with the dots. This box with the dots can help you to change the type of the variable. And then you can choose the decimals. Now, if you go to the data view, look at the D2E variable, DE variable. It's 10101010. Now, you know why this is so? Because I didn't choose any decimal places for D2E ratio. And if I choose it, guess what happens? Oh, I chose too many zeros, so it says, no, chap, you're too greedy. Maybe 4. Okay, maybe 3. But why can't I have this more than 1, 2? Yeah. And now you see the data view and see. Look, earlier it was showing as 0 and 1, but now it has changed. So always make sure that you have certain minimum number of decimal places. I made it 3. If I try to make it 4, well, maybe 3 is the highest accepting, no problem, 3 is fine. And you can see that now the variables look better, the D2E ratio. Some companies have 0 debt, so the ratio would be 0. So what can we do? Nothing we can do. Look at this company. This is, this company's D2E ratio is 2.36. 2.36 means for €1 of equity, the company's debt is 2.36. So this data belong to many companies, and these companies are in the first column basically. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These all are companies, and I think we have around 110 companies in this exercise. Anyways, and some companies have no debt. Well, there's no debt. It means the ratio is 0. I want to bring your attention now back to. Do you have any questions so far? Okay. I want to bring you back to the data view and look at the variable innovativeness. Even though I changed the decimal places to 2 or 3, still the variable is 1, 0, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, like that. So it's only 1 and zeros. Uh, if you look at the other variables, for example, D to E, this is the actual debt of a company divided by the actual equity of the company. But if you look at the innovativeness, it is 1, 0, 1, 0, 1, 0, and so on and so forth. Why it's so? There's a reason for it. It's like a yes and no. And if we have yes and no response, then we explain them with the binary form. Have you heard the binary? We use the computers. When you make the computer programming, you can only write one binary variable, we call it, and we also call it dichotomous variable, dichotomy. Dichotomy means this way or that way, either 0 or 1, extreme variables. So there's nothing between 0 and 1. Either it exists or it does not exist. There are many variables in empirical research where you have to use the binary variable. For example, male, female, 1 and 0. Urban, rural, 1 and 0. Rich and poor, 1 and 0. Honest, dishonest, 1 and 0. Peaceful, unpeaceful, 1 and 0. So there are many situations in empirical research where you cannot measure the variable as such. And you might have to use the qualitative variable or the binary variable, or as I said, it's called dichotomous variable. It's a dichotomy. Okay. You can challenge me that Shab, innovativeness can also be calculated by. Now, okay, may I ask you one thing? If I don't want to choose innovativeness as a qualitative variable, how else I can choose? Is any way I can measure innovativeness of a company quantitatively? And this is a question to you.
I think you can see, for example, R&D.
Yeah.
And see how many engineers they have.
Yes.
Things like that.
Yes. Very good. Santu has said very good point. He said that there is a way, there's a quantitative way to calculate innovativeness. You can, for example, you can calculate the company's research and development expenditure and divide by the sales of it. So R&D to sales ratio could be a measure of innovativeness. Any other measure of innovativeness? I have at least one in my head.
New products.
Huh?
New products.
The new products launch. I want to look for some very easy variable, which is easy to detect, actually, which is easy to identify. I would say that if I go to the balance sheet of a company and I find the intangible assets, the ratio of intangible assets to total assets. So if I can find the intangible assets of a company, and of course I can find the total assets, and the ratio between the two could also be a measure of innovativeness. So what lesson we learn from here is that a variable can be measured by different ways. So you can measure, for example, if you want to see the well-being of people living in Uvascula, there are many ways. You can see how many schools we have in Uvascula for per 1,000 of people living in Uvascula. The one measure of well-being is that how many hospitals, beds, or how many doctors per 1,000 of population we have in Uvascula, how many nurses we have, how much money has been invested by city council on buying medical equipment. So there are so many ways to measure a variable. It can also be one measure that how many crimes have been committed in Uvascula during the year. Because if there's a less crime rate, it means the well-being is better. You can also see the well-being of people, that how how much is the density of the local transport, the public transport. So if these green buses, if they run more frequently, that also shows a measure of well-being of people, that people are living in a nice way because they have very good means of transportation. The public transport is so good. So a certain variable can be, and by the way, you can also see how many primary schools we have, how many Paivakotis, how many daycare we have in the city. So a variable can be measured by many ways. And here on purpose, I chose this binary variable because all the variables are numeric, quantitative, but this is the only variable which is qualitative. So it happened that sometime our variable is not quantitative, but qualitative. And we have to, even the qualitative variables, we need to measure them. And the only way to measure the qualitative variable is by using this proxy 0 to 1, the binary, or sometime we also measure on scale if we have more responses. For instance, about male, female, about urban, rural, you can use 1 and 0. But sometimes we ask people the responses: strongly agree, disagree, strongly disagree, no response. So in that case, 0 and 1 are not enough because we have 5 responses here now: strongly agree, disagree, strongly disagree, and no comment, no response. So in this case, we can measure it by 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, whichever way. So we need to put some numeric values to assess some qualitative phenomenon as well. All right. So we have these variables, and you can see there is a sign like balloons. You can see if you change it to, for example, innovativeness is because it's only scale-based 1 and 0. So you can see the sign is different, but as long as these are not string variable, it's okay. All right. Now it's an important point that I asked you, that if you have any questions, queries. So this is a little bit of basics. I repeat, in SPSS space, you have data view and the variable view. You can simply bring the data from spreadsheet, but be careful, be careful. One thing I really want to warn you, and I had this problem today. In my computer, I have decimals, not the comma separator. Do you know what I mean? In Finland, we normally, the built-in system is that the decimal is with a dot, not by, the decimal is basically the comma separator, not the dot separator. And I had my home computer, which is having the dot, not comma. And when I copied and pasted that data in SPSS, it was not working at all. So I had a lot of problem. And then somebody told me, my friend told me that, you know what, Shab, you're doing something silly because it's the way the software is customized. It accepts comma, not the dot. And then what I did, I changed the data to, so I made a change. I replaced all the dots with comma.
You can do it by the settings as well.
Yeah, you can do by settings as well. But yeah, I like some. Yeah.
Why always when you download stock data, it's by comma, and when you download index data, it's by dot?
Really?
Yeah.
I never noticed it.
Many times for me. I hate it.
Okay. That's strange. I didn't notice.
To realize that, what's wrong with it?
Well, I think it's safer to be having the comma separator in Finland because mostly the computers are more compatible to comma than dot. But anyway, we are here. So let's go to the first analysis I want to do with you is that, are you guys okay? Because you are very quiet and I'm feeling really scared of your quietness. All right, so in empirical research, we have 3 stages. Normally, if you look at all the theses which I have supervised in thesis.phi, I have 3 stages of analysis. The first analysis which I have is called descriptive analysis. Descriptive. Look at the word descriptive. Descriptive means it only describes something, but it's not a conclusive proof. Like, for example, if the crime is committed and the cops come at the crime spot and they are asking people, hey, what happened? And people tell, oh, yes, this happened, that happened. That's only a description of the incident. But that doesn't mean that the conclusion is made who committed the crime and what happened and put the guilty behind the bar. So it's more like a curtain raiser, the first point of contact. So when you want to see how your data analysis looks like, the first point of contact is descriptive statistics. But be careful, don't make any conclusion based on descriptive statistics. It's only described. It's more like the first point of contact or the introduction with the data. Now, how do we do it? Very simple. You can see here, now we again have to go together, all of us. Can you see here, analyze? Click analyze. Yeah. Go to descriptive statistics. So just see the yellow part highlighted. Analyze, descriptive statistics. And then you have a choice. Either you can go to frequencies or you go to descriptive. It's up to you. But let's go to descriptive. So I repeat, analyze, descriptive statistics. And once again, you see a descriptive here. So just see these 3 yellow steps. 1, 2, 3. And then we click this one and we have this kind of activity area. So what I do here, normally when you see it, maybe I was trying it already. So when you see it, they all will be in the dugout. Now see, have you heard this word dugout before? You know what is dugout? You like football? Yeah. So when the match start, before the match start, all the players, so all these variables, call them the players. They are not in the field. This is your playing field. Look at the cursor. This is a football pitch. But before the match begins, they all are in the dugout. How many players play in the football match? 11. And how many players are in the team? Huh? Okay, let's say that they're more than 11 at least, right? Now, you don't bring all the players together here in the team. Can you, in the pitch? No. So you make a decision that how many players will show up in the pitch. But the moral of the story is that when you click this analyze, descriptive statistics, and once again descriptive, you see that all these variables are appearing here in the dugout. I call it dugout. And then let's say I choose all of them. I can choose control or, and then select all of them, and they come here. Now they all are in the pitch. They all move to the pitch. You can bring them one by one. You can even make a choice to bring those variables in and out. For example, I may choose not to have D2, I may choose not to have innovativeness, because innovativeness is all 1 to 0, okay? So if for example, if I choose not to have innovativeness, I can send it back. But if I want to bring it in, of course I can bring it in. So look, there is an arrow here. The arrow is used to bring the variable in and out. It's the way we work. Now, these players, variables were in the dugout. I choose all of them, let's say, and I bring them here in the football pitch, the activity area. And then I have the options here. Look, and when I click the options, I get mean. Mean means the average, the standard deviation. Normally, I would choose either standard deviation or variance, because variance is the square of standard deviation. So why to have the same thing twice? The way normally I take mean, standard deviation, the minimum value, the maximum value, and the range. Okay, and then I continue, and then nothing much. I click OK. I repeat, you have the variables in the activity area. Click options. In the options, the standard descriptive statistics are mean, standard deviation. Look at the tick. You can see minimum, maximum, range, and that's it. I don't think there is anything else required. Continue, and then OK. You click OK. You see what? You see the table of output. This is your first output. So you can see that revenue of 110 companies. The highest revenue has been 2918, and the minimum has been -3, and the difference between the maximum and the minimum is range. So range is, for example, if I organize the exam in the class and the highest marks are 10, the maximum marks are 10. Sorry, no, there's no need to do it. The maximum marks are 10 and the minimum are 2. The range would be 8. 10 minus 2, 8. And mean is 59.58, and the standard deviation is 286. Remember, standard deviation is how much is the variation in the data. Higher the standard deviation, more is the inconsistency in the data. Ideally, we want to have the standard deviation as low as possible, because larger the deviation, look at the word deviation, more the variation in the data, lesser we would be conclusive to prove something. Now imagine, you go to the crime site, the cops are at the crime site, and they're just wondering what happened. And almost everybody is telling the same story. Same story. And the cops are totally convinced. But for example, if you go to the crime site and people are either very skeptic or they're giving very contradictory statements. So in that case, it's very difficult to conclude the output, the outcome. It means it requires further investigation. So therefore, it's very important that you look at all these descriptive statistics. These are, as I said, these are the curtain raisers. These are only the data which brings you the basic introduction to the data, but you can't really make a conclusion out of it. But this is something customary we have. If you look at the thesis, in thesis.free, you'll see that the students generally, first of all, calculate the descriptive statistics, okay? I just take a short break here, but not the break, the real break, but I want to take you to the, to my screen. So for instance, if I take you to thesis.free, and if I type in my last name, and there's a girl from Sophia, she wrote a fantastic thesis actually. So if I search for this thesis and I find here, Sophia Lulu, and this is her thesis. I hope you can see. And if I choose the PDF, this is how her thesis look like. But the thing is that I want to take you to her descriptive statistics. What is that? Here we go. Look. This is called descriptive statistics. This is a perfect example. So she has these variables. Don't worry about what these variables are. You will also have your own variables. 250 companies, the maximum value this much, the minimum value this much, and the range is this much. So the range is the max minus min, maximum minus minimum, the range. The mean is here. The standard deviation is here, 41, basically. And 250, because 250 was her sample size. So this is the first point of interaction with the data. The first point of interaction with the data is called descriptive statistics. So phase one, this is phase one of analysis. We have 3 phases of analysis. The first phase is called descriptive analysis, which you know what to do. You have done it by yourself, I hope. And the second one is called correlational analysis. And the third one is called regression analysis. It's more like a cause and effect. So these are the 3 types of analysis that we shall be doing in this track. You may do, if you do the qualitative thesis, you don't need them, but I think being the student of finance, it's very important for you to know these basic fundamental analysis tools. We will do the advanced tools also, but today I just want to focus on the basic ones. Okay, and now I take you back to the SPSS space. Goodness me, where are we? Here, yeah. Okay, before we go to the break, I will do the second phase of analysis called correlational analysis. But before I go to correlational analysis, I want to ask you if you have any questions, comments, or any query. Only then we move further. But may I ask you, have you done this thing before? Have you or have you not? Okay. But this, I tell you something, this is a very important tool. It's not so complicated, but it's a very important skill you learn. I somehow feel that we should give more opportunities to the students to learn analytical tools. Data analytics is a very important tool, very important skill these days. And if you know this basic skill, believe me, it can make a lot of impact on you. All right. So without any further ado, I take you to the second phase of analysis called correlational analysis. Are you ready? Are you ready? Are you feeling bored? Are you feeling sleepy? Okay. How about my friends, online friends? Are you guys okay?
I sent a message to ask if we have something, but they said it's okay for now, and they are good.
They're good. All right. Okay. I'm happy. I trust you. I trust all of you. Let's go to analyze now. Hey, now see analyze once again. Look at this. Can you see here correlate? Can you see this yellow, yellow? I will not say further. You know what is the rhyme, yellow, yellow? Huh? I will not say yellow, yellow, dirty fellow. So it's just yellow, yellow, yeah? Yellow, yellow, and look at the bivariate. Can you see here? Can you see these three steps? Analyze. Remember, the most common tool in SPSS Workspace that you will be using is called analyze. Everything is about analyze. I myself feel more comfortable with the data in Excel and analysis in SPSS. Okay. I don't change the nature and format of data in SPSS. Whatever I need to do, I do in Excel, and then bring that spreadsheet to the SPSS. Anyways, so analyze, correlate, and bivariate. Bivariate means two variables at a time, and you can see here all the variables are in the, where are they? Where are these variables? Huh? In the dugout. You cannot make players to play in dugout. You have to bring them to the pitch. So what we do here, we select all of them, or at least you have a right to choose who you don't want to bring. Remember, you are not forced to bring all the variables in the analysis. If there's 1, 2, 3 variables which you don't want to include in the analysis, just don't select them. Or if you select them, you can deselect them afterwards. So let's say that I bring all of them here. And guess what? Look, by default, there is a tick against Pearson. Do you also see that? Huh? Pearson is the name of a statistician. His full name is Carl Pearson. And he is the scholar, researcher who developed this technique of correlation analysis. Okay, there's another correlation which I really like called Spearman's rank correlation, but I will not go for it. The most common correlation that we use in the data analysis is by Carl Pearson. And then, can you see here two-tailed and one-tailed? Huh? Do you know the difference between two-tail and one-tail? Have you got any idea what is two-tailed and one-tail? Okay, now I take a pause. I need to explain what this two-tail and one-tail is, but very quickly, don't worry. I will not take too much of time of yours for this thing. Generally, draw, okay. If this is a straight line, and let's say the center is here, right? Can you see the cursor? The average. Have you seen this kind of shape before, the normal distribution? And it comes in the middle, yeah? So it divides the data in two parts, the right side and the left side. The average is this, let's call it average. I call it X bar as average. Some values would be lying here. Some data is here, and some data is on the left side. Sorry. If you only want to analyze either right tail or left tail, so if you want to analyze only the one side of the tail, then we call it one-tailed test. If you want to test both sides of the tail, then it's called two-tailed test. Two-tailed test. Are you with me? If I only want to test the right side, then it's called right-tailed test or only left-tailed test. So either way, it's a one-tailed test. But if I want to see both tails together, then it becomes two-tailed test. The question is, what is the real life example of one tail and two tail? Now, listen this fictitious example carefully, very carefully rather. If I'm the person who develops some new diet, some new food, some new medicine, for example, and my claim is that this diet would actually make you healthy. Yeah? My claim is that this diet will make you healthier than before. What should you do now? My claim is that this diet which I develop will make you healthier.
I should call you a liar.
Okay. All right. I'm very delighted to know. The only time, now listen carefully, this example is very important. My claim is that this food will make you healthier than before. The only time you can prove me wrong is if the food which I develop is unhealthier for you. So if I make you healthy, which I claim, my claim is proved, isn't it? You have no problem if my food makes you healthier, but you definitely have a problem if my food makes you unhealthier. So for example, let's say this is the average health in the middle, the right side is healthier, and the left side is non-healthier. Let's say the average food index is 50. If it is more than 50, it's good for you. If it is less than 50, it's bad for you. It means that you have no problem if this diet is more than 50 number, but you have definitely a problem if the food is less than 50. It means it becomes essentially a one-tailed test. Because you don't give any bother, you don't bother on this side, because it's all, it makes you happy, but you are very unhappy if it is this side of the. Same way, my claim is that my lecture would make you educate more skilled, and this is the average skill level. So right side more skilled, left side less skilled. You have no problem if you're more skilled, but you definitely have a problem if it is less skilled. It means you are more concerned about the one side of the tail, not the two sides of the tail. So in that case, we use one-tailed test. But if you look at the SPSS, new share, yeah. But if you look at the SPSS Workspace, it by default is two-tailed. You may choose one-tailed, but I will not recommend you to make, because we normally want to see a bell-shaped normal distribution curve. So let it be two-tailed. Options, no, there's nothing. And here is any style thing, so no, nothing. I want to see the options once again. No, there's no need for it. And I click OK. Here we go. And you can see the correlation table showing up. Can you see the correlation table? Okay. Now see what? Here, I want to give you a 10 minutes break. When you come back, we shall try to decode this table, that what information, what knowledge we gain from this table. What does it tell us? And how much should we believe it? This we shall study when we come back. So it's 25 past 2. So at 2:35, we resume. Take a short break. So I resume it now. So this is the correlation output we get given to us. Now, be careful. You can see that the same variables are in the row wise and then column wise also. So it's like a matrix. It's like a matrix. And of course, the correlation between revenue and revenue will be 1. So there's no doubt about it. But I want to bring your attention to a point. For example, have a look at the correlation between revenue and innovativeness. I want to draw your attention to how to read the correlation between revenue and innovativeness. The correlation between revenue and innovativeness is 0.150. Is it positive correlation? Yes or no? Is it positive or negative correlation? Positive. Where is the negative sign?
Yeah.
So the correlation is not very high, but it's a low but positive correlation. Low but positive correlation. Yeah? Make sense? But now, the most important thing. The most important thing is how much we trust that this correlation is really genuine and not because of some randomness. It's not a game of chance. It's really a genuine correlation coefficient. When you want to see that how genuine the correlation is, we look at the word sig. Can you see here word sig? Sig means significance, the level of significance. And the level of significance here is 11.9%. Can you see here? 11.9%. Yeah. I don't call it 0.119, but can I call it 11.9%? Yes or no? Yes? Can I call it 11.9% or not? Yes, other people. Who says that it's not 11.9%? Who have a doubt? Any level of significance more than 10% is unacceptable to us. Now this number you need to remember, I will make it more clear as the discussion follow. Any level of significance which is more than 10%, this is 11.9%. Any level of significance which is more than 10% is unacceptable. It means that, of course, there is a correlation between innovativeness and revenue. Of course, it's positive. But this is not significant enough. Like, for example, sometime when you are a crime investigator, you find that, hey, you know what? These are the 3 people who I really suspect to be the guilty people. You get my point? But my investigation shows that I don't have enough evidence to convict them. And what do you do then? Then you give them the benefit of doubt and release them, or do you hang them because you have a doubt? The benefit of doubt is always going to the criminal, isn't? Do you get my point or not? It's very important. Can you hang a person just because you suspect it? No. If you have a doubt, you always give the benefit of doubt to the person who is accused. So in this case, it means that even though there is a correlation between revenue and innovativeness, but we don't have enough evidence to accept it. And what is the level of acceptance? 10%. Okay. Now see this one now. I want to bring your attention here now. Firm operating profit ratio and market operating profit ratio. How much is this? It is 0.331. It is 0.331. Is this correlation positive or negative? is the correlation between firm operating profit ratio and the market operating profit ratio, is it positive or negative? Positive. And what is the level of significance? Should we accept it or not? Is this correlation genuine or not? Definitely genuine, because we can accept the doubt up to 10%. Here, in this case, the doubt was 11.9%, which was more than 10%, and we didn't accept it. But here the doubt is 0%. The doubt is 0%. Hence, our confidence is almost 100%. So we can say that the correlation between the firm operating profit ratio and the market operating profit ratio is accepted, because it is the significance. Significance means the level of doubt is nothing, no doubt. So you can say with almost absolute confidence that this correlation between two variables is genuine, positive, and genuine. Same way, have a look at this one. The next value, the correlation between firm operating profit ratio and debt to equity ratio is positive or negative? Is it positive or negative? Negative. How about the doubt level? Accepted, because the doubt level is 5% here, 5.3%. And how much doubt we can accept? 10%. It's below. Accept it. Hence, the correlation between the firm operating profit ratio and the firm debt equity ratio is genuine. And if the correlation, the significance level is more than 10%, we don't accept it, because then the level of doubt is more than 10%, and 10% is the maximum limit we can give somebody benefit of doubt. But if it is more than 10, we don't accept it. Okay, so if I make a picture and I share my screen with you, so here, let's call it text, okay? Significance level. And then I say confidence level. Confidence level. If the level of significance is 10%, I call it in decimal, so 0.10, sorry, 10%. Then the level of confidence will be equal to 1 minus 0.10. Hence, I can say with 90% of confidence that this result is genuine. So if the level of significance is 10%, then I can say with 90% of confidence that this finding is genuine. If the significance level is, let's say 11%, then 1 minus 0.11 is equal to 0.89. So then our level of confidence is less than 90%. We never let our level of confidence fall below 90%. Don't ask me why. It's a common accepted tradition among researchers that no level of significance more than 10%, hence no level of confidence less than 89% is accepted, up to 90%. Some researchers don't even accept anything more than 5% level of significance. But I think up to 10% is okay. And if your level of significance is 5%, it means that your level of confidence is 1 minus 95%, basically. And if it is 0.0%, remember I showed you one case when the significance was 0%. In this case, Your level of confidence is basically 100%, which is 1, basically. So this is how we do it. And I can show you one level of significance. I just showed you somewhere, I think, when it was, when significance level was 0. It means you can see with 100% confidence that this correlation between P to E and firm operating profit ratio is negative, but highly significant, absolutely significant. So it means that we can filter out. So I want you to find out in this matrix, and this is a task for you, find out those two variables who are having insignificant relationship with one another. So have a look at this matrix and find out that set of variables who you think have no real, genuine, significant relationship with each other. Okay, I take a pause here and I give you this job. How about the correlation between the firm stock return and the innovativeness? You know what? How to interpret this is, look at this. It basically means that those companies who are very innovative, their stock return is very high. Look, the relationship is positive, yeah? And not only positive, this relationship is genuine, right? How about this one, by the way? No, wait a sec. I want to see something which is almost at the bottom line. How about this one? The correlation between the debt to equity ratio and the stock, the index return. How about this one? Accepted or not?
No.
Not accepted because it's more than 10%. See, it's just little bit below 10%, but we don't accept it. It's 13.1%. So now you know what you basically means, yeah? So this is how we read the correlation. So the few things, the matrix appears, you should see first whether the correlation is positive or negative. But before you make a conclusion based on this result, you should check if this correlation is genuine or is it just a by chance. If it is a by chance correlation, then the level of significance would be very high. And as I showed you, that if the level of significance is more than 10%, we don't accept it because then the level of confidence goes down. The level of confidence should be 90% to 100%, which means the level of significance should be 0% and 10%. So this is the max limit. That's why I was telling that never accept anything more than 10%. We have one case when it was 0.113, but we still don't accept it. You know why? Because then we can't give more, we don't want to give them the benefit of doubt more than 10%. 10% is a maximum benefit of doubt we can give to something, not more than that. Okay, now for next 15 minutes, I want you to recall whatever we have studied today. And if you want to bring to my notice something which you want me to do again, I will do it. But I will not discuss any more topic today. Next week when we meet, we shall do regression, and then we shall also do some advanced analysis tool. But next week I'll be a bit fast, because then I will not tell you that how the data comes here, decimal, comma. I will not go into that kind of discussion. So then I will do more straightaway calculation. But today, in the rest of the time, you can, if you have any technical issues, you can ask me. But as I said, broadly speaking, we have three layers of analysis: descriptive, correlational, and regression. Regression and then further advanced. So next week, we shall do regression and more advanced analysis. I want to show you that how much we use this kind of tools in the empirical research, and I will share the same thesis by Sophia Lulu with you. So she used correlation, but then she goes further to regression. This is how the regression look like. So it means she also used the same way. So this is a common path. And you can also see here the correlation. So you can see the X, X1, X2, Y1, Y2, and you can see that the level of significance here. So this is a very commonly used tool in statistical analysis. And you don't have to type it. And guess what? When you want to type this result in your spreadsheet or in your Word document, look, you can simply copy and paste it. So if I want to copy this correlation thing between the variable, all I need to do is copy. Yeah. Yeah, so basically I copy it. Okay, I repeat. When you want to move these calculations to your Word document, because you will write thesis in the Word file, don't you worry, you don't have to write them again. You can just copy this information. And if you go to the Word file, empty Word file, all you need is to just paste it. So or if you want to paste special or something. Why can't I actually edit? Find in a table. No, not here. File, edit. And this one. Yeah, so well, at least we can paste it. But I think we have better copy and paste options, which I will discuss with you. Somehow I'm not able to do it.
I think you can save it as a picture in there.
Huh?
You can save it as a picture and then save the picture and like that.
Or I can actually paste it here in Excel. Yeah, this is also fine. So if it doesn't work very well in Word, you can paste in Excel. Yeah, this works quite okay. And then from once you have the data in Excel, then you can paste in the Word file. So, well, these are very different things. Many things we can do, but you don't, when you find this analysis, you don't have to type everything again. Basically, you can just use the copy and paste function. But I'm just wondering if you can straight away export it to the table. Or can I do this way actually? Hey, copy as, yeah, there we go. I think this is the right way, that you find it, copy as. So here you can choose, for example, as an image, as a plain text, or Excel. So if I choose like this, yeah, this works. I don't think there is any, I'm still working out. I'm not convinced yet. So if we copy it as a table, or image. So if I copy it as an image, what difference does it make? Well, not much, but maybe in the Word file it makes a difference. Yeah, it's like an image now. Yeah, it works actually. Yes, please let me know if you have any questions. Otherwise, I would recommend you that once this recording we get, then I can share the recording with you and perhaps you can watch it again, because this is a little bit different thing. And as you said that most of you haven't done it before, so it's not a good idea, well, to make a conclusion right now. So maybe once you get the recording, so it's not a bad idea to watch it again. And if you have any questions, we can clarify them. All right. So no questions, nothing else? Well, in that case, we can close our meeting for today. But I strongly advise you that when we meet next week, be prepared of these basic technical issues, comma, decimals, these things, copy paste stuff, so that we can focus more on. So I will not say anything about the workspace of SPSS. We will be straight away on calculation and analysis. But this is a good thing you have learned, this how to understand the level of significance, because the same level of significance will be used in the regression as well. So that's it for today. And thank you very much for your participation and your patience. And we will now meet next week. Until then, bye-bye.
Bye, Shah.
Bye-bye. Sorry, say it again.
Do we save this file or?
I think I strongly recommend you that before you guys come out of Workspace, save it. Save your data. Save this file somewhere. I hope you have the option to save. You have the option to save? Huh? You haven't saved it? No problem. Well, in that case, I can send it to you again. Yeah, no problem. If you haven't saved, it's not a crime. But if you can still save it somewhere, then it will be easy for you. But if you haven't saved it, I can send the link to you.